Hi everyone, today's lesson is on branched hydrocarbons. So up till now we've been talking about organic molecules that were all in this straight looking line, like this first example right here. And we were naming them, but a lot of times organic molecules are not all in a row like this first example. A lot of them appear like this second example here, where we have carbons, but we have some of them that are not exactly in a row. So how do we go about naming those? Well, let's go back and look at the first one here and name this one. So you should know how to do that one already, and then we'll look at the second one and learn how to name that. So we are going to count the carbons, 1, 2, 3, 4, 5 carbons. So that has the prefix of pent. They're all single bonds between the carbons, single bond, single bond, single bond, single bond, okay? And there's no functional groups, so it just gets the pentane ending. So the name of this first molecule is pentane. What about the second molecule? Well, if you notice, I have the same number of carbons, 1, 2, 3, 4, 5 carbons. But they're not all in a row. So this second one is not pentane, but it is an isomer of pentane. And an isomer is simply a chemical that has the same formula, but a different structure. So this has the same number of carbons and the same number of hydrogens, but they're not put together in the same fashion. So this is an isomer of pentane. And what do we call this? Well, let's go through some of the rules of naming these branched hydrocarbons. And we call this like a branch off a tree. This right here, it's a branch off the main line of carbons. So write these down, the list of things you should do. So the first thing we're going to do is find the longest carbon chain, and sometimes that is not horizontal left to right. So follow the carbons and find the longest carbon chain. Then go ahead and name that as usual. After you've done that, identify the branches. You can circle them or just make a mental note of them. And look at the branches. Count how many carbons are in the branch. And we're going to use the same numbering system as we did before. 1 is for meth, 2 is for eth. But this time, we're going to add a YL to the ending. So a branch that has 1 carbon is going to be called a methyl branch. A branch with 2 carbons is going to be called an ethyl branch. So go ahead and name it with a YL ending. After you're done with that, you need to locate so you can number where the location of the branch is. So count the branch's location from the closest end. So from left to right or right to left, it just depends on which is closer or which gives the smallest number. And then the last step, you can have more than 1 branch. So if you have more than 1 branch, you're going to name each one and number each one. And if you have more than 1 methyl group or more than 1 ethyl group or more than 1 propyl group, you're also giving those a prefix. And this time we use the prefixes similar to what we did for inorganic compounds. If you have 2 of them, we're going to use di, tri, tetra, penta, those prefixes. So if I had 2 methyl groups, I might be at the second carbon and the third carbon. It would be 2,3-dimethyl, maybe heptane or something like that. So let's go back and name that compound that was an isomer of pentane. So let's go through the steps. We're going to find the longest chain of carbons. So 1, 2, 3, 4 is the longest I can get. I could go 1, 2, 3, 4 this way. That's also the same. But if I go this way, I can only get to 3 carbons. So 4 carbons is my longest chain. And 4 carbons is bute, B-U-T. And they're all single bonds, and there's no functional group, so it's a butane molecule. But it's a butane molecule with a branch, and here is the branch, right here. The branch contains 1 carbon, So that is the meth prefix. And we're going to add YL to that. So it's a methyl branch. So this is methylbutane. And we have just one more step, and that's to say where this methyl branch is off of. So we're going to count for the closest side, which is this side, 1, 2, so it's off the second carbon. If you count from the other direction, it would be 1, 2, 3. So wow, this is getting a little messy over here, but hopefully you can still see it. So this is 2-methylbutane. So we call this 2-methylbutane. Oops, and I didn't spell methyl right. So let's fix that up. And let's spell that properly. methyl. So this is 2-methylbutane. So it has 4 carbons in a row. They're all single bonds. Off the second carbon, there's a branch. This branch contains 1 carbon. So this is 2-methylbutane. So hopefully you're getting that. Let's try one more, and then you're on your own. Give it a try, see how you do. If you have questions, ask in class. I think they're kind of like a puzzle, so I kind of have fun with them. So hopefully you have fun naming them also. So here's this crazy squiggly thing, which you learned about in the previous video, that this is an organic molecule, and at each end and each point, there's a carbon. And notice I don't see any functional groups. I don't see any double bonds to O's or OH's or any N's. So I don't have any functional groups, but I do have some branches. So I'm going to try to find the longest chain. And so let's count. 1, 2, 3, 4, 5, 6, 7 if I go this way. If I go straight across, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Can I get longer than 10? I think if you go out one of these branches, you'll find you won't get any longer than 10. So this is dec for 10. They're all single bonds, and there's no functional group. So this is a decane. But it's a decane molecule with some branches. So I have a branch here, a branch here, and a branch here. So these 2 branches contain only 1 carbon. That's at the end here. And so if they only contain 1 carbon, they're a methyl branch. This branch contains 2 carbons, 1, 2, so that's an ethyl branch. So I'm going to have to number each one. So I am going to start counting in this time from right to left, because if I count from left to right, I go 1, 2, 3, 4, 5. This one occurs on the 5th carbon. If I count from this way, 1, 2, 3, it occurs on the 3rd carbon. So I'm going to count from the shortest end, because here I'd have a 3, a 4, a 5, and a 6, and that's smaller than a 1, 2, 3, 4, 5, and a 7, and an 8. So I'm going to count left to right. Now remember, this is a 3-dimensional molecule, so I could just flip it over and it would be, I'm going to count from right to left, but I could flip it and it would be left to right. So now I'm going to go ahead and name this. So I have a methyl group on the 3rd and 4th carbon, and I have an ethyl group on the 6th carbon. So I'm going to call this 3, 4. There's 2 methyl groups, so that's dimethyl. Then I have an ethyl group, so I have 6 ethyl decane. Wow. So notice it can get pretty long. So this is 3,4-dimethyl 6-ethyl decane. And there you have some naming. The best way to learn this is to give them a try yourself. So ask questions if you have any in class. And thanks for listening.